Okay, next we're going to do one right here. We want to rationalize the denominator, is what the directions would say. So here, now the square root of x to the third, I could simplify that, but it would still leave an x on the inside. So for right now, what I'm going to do, I'm not worried about the 3 out here, but I'm just worried about this part. And I need, if I want to get sets of 2, I need another x in here so I can get sets of 2. So I'm going to multiply by the square root of x on both levels. And so what I get is the square root of 3x on top. On the bottom, I get 3 times the square root of x to the 4th now. And it's at this point then that I can now solve the squares, because I'm looking for sets of x squared. And I have 2 sets of those. So I can now call this the square root of 3x over 3 times x squared. And there you go. We've been rationalized. Okay, let me turn the page here. Find the next section. Mom's turning the light on. That's okay. Thank you, Mom. Okay, so here, this one looks more complicated, doesn't it? But again, just like before when we were simplifying these radicals in the earlier part of the chapter, you're looking for things that you can find sets of 3, like 9, I don't know the cube root of 9. I know the square root of 9 because it's 3 times 3. But I need 3 cubed, so I'm going to need more on the 9s here. So what I'm going to do is I'm going to multiply, give it another 3. Because this is 3 times 3, and this will give me the third 3. And then I don't have 3 y's to be able to simplify this, so I'm going to give it another one. And I only have 1 z, so I'm going to give it 2 more z's. Okay, and so I'm going to do the same thing at the top. Don't forget to do the top, because that can really, oops, don't forget your indexes too. I always forget those. Okay, that always causes problems when I type in my answers. Okay, so this is the thing that we are multiplying by on both levels so that this denominator will be solvable. Alright, so let's see what we have. We have the cube root of 9 times 3 is 27, because I did 9 times 3. And then we have y squared and y, so that gives us y to the third. And we have z times z squared, which gives us z to the third. On top, we're going to multiply these. So on the outside, we have x. And then on the inside, we have 3y squared z squared. Okay, so we just collected those y's and the z. All right. So now what? Well, we can find the cube root of 27. If you recall our list of cubes here, 27 was on there. 1, 2, 3. 3 cubed is 27. So when we solve that, that brings a 3 on the outside. And then we do have 1 set of y cubed, so that's y. And 1 set of z cubed, and so that's z. That's our denominator. So up here, we have 3 y and z on the bottom. On the top, we couldn't really do anything with that. There weren't any sets of 3, so we just leave it written as that. Okay, now things are going to get a little more interesting. Sometimes you just cannot multiply by this. Sometimes it's the same thing, or like what we just did. Sometimes it's more complicated in the denominator. If you'll notice, this one has addition or subtraction in it, and that's what the next video is going to talk about how to handle it when there's addition and subtraction in the denominator. And the key word that you want to be aware of is conjugate.